Okay, today we're going to talk about the discriminant for a quadratic equation and the number and types of solutions that you guys can have. So just want to give you that information here at the top. There's a little formula for this. So the discriminant of a quadratic is b squared minus 4ac. It is literally just a copy of what you see under the square root in your quadratic formula, but it does not include the square root. And if you evaluate that expression, you're going to get several different options, and that's what I've got in the table going on here. So I'm going to scooch this up just a little bit. All right, so I'm literally just going to make up, like, let's say we went through and did the quadratic formula. This is what it looked like, so you guys can see a little example. So if that value is negative, so if I do b squared minus 4ac and it's negative, and again, I'm just going to make something up. So let's say I did the full-on quadratic formula and it simplified and I had 4 plus or minus square root, and like I said, I'm just going to make something up. So negative number for b squared minus 4ac would mean this would be negative if I was looking at the quadratic formula, and let's just say that was over 2, just as an example. Okay, anytime the discriminant is negative, so that value would be negative there, that's going to tell me, and I picked a perfect square in imaginary land to simplify this a little bit, but this would give me 2 different answers, right, because of the plus or minus symbol. So anytime your discriminant's a negative number, you're going to have 2 imaginary solutions to your quadratic. Anytime whatever's under the square root is negative b squared minus 4ac, 2 imaginary solutions. What I have here to the side is just what that might look like on a graph. I just totally made this up, so these graphs are not related to that information there. But basically, if you were to graph the quadratic, we can solve by graphing and seeing where it crosses the x-axis. If you have imaginary solutions, that just means your parabola would not ever touch the x-axis. So could turn up and not touch the x-axis, could turn down and not touch the x-axis. That's what's going on in those diagrams. So this would not intersect the x-axis if your discriminant was negative. 2 imaginary solutions. Okay, let's say you evaluated b squared minus 4ac and you got 0. All right, so I'm just going to make something up. So let's say I was doing my quadratic formula, got down to here, and again, I'm just making up some numbers, but my discriminant would be my b squared minus 4ac. So let's say that was 0. Now, what you would end up with here, you can take the square root of 0, but 5 plus or minus 0 is just going to be 5, whether I add 0 or subtract 0. So that would just give me one answer. Okay, so this is going to give me one real, and what I'm going to call this here, rational solution. And rational just means can be written as a fraction. And you won't have any radicals in that scenario, because if my discriminant's b squared minus 4ac of 0, I won't have a radical if I would do the full-on quadratic formula. So my answer has to be a real rational, meaning I could write it as a fraction solution. The reason I'm emphasizing that is going to go with our last part of the table, but before we move on to that, if you just have one real solution on a graph, what would that look like is what we have here, just 2 different examples. It just means that the vertex would be the actual solution. The vertex would be the only point that would touch the x-axis. Okay, now the final thing that can happen, excuse me, and I'm going to split this into 2 different categories. All right, so if I get b squared minus 4ac is a positive number, all right, 2 things can happen. So let's say, again, I'm just making something up, and I ended up with 3 plus or minus square root of 25. I'm just making this over 2. Okay, now, if I actually simplified that, that positive number is a perfect square. So if that happens, this would be 3 plus or minus 5 over 2 as my little example, 25 being the positive number for my discriminant. Those are going to give you 2 nice numbers. All right, so if you have positive and it's a perfect square for your discriminant. 25, 36, 49 perfect squares. If it's positive and it's a perfect square, this would give you two different answers, and I'm going to say two real rational solutions. Two real, basically nice numbers that we could write as a fraction if you have a positive discriminant and it's a perfect square. Okay, other thing that can happen, again, I'm just making something up, so let's do, I don't know, 6 plus or minus, let's say we got 17 when we did b squared minus 4ac. So not a perfect square, but a positive number. So if it's positive, but not a perfect square, so I couldn't take the square root. Or I could break it down. It could be something that I could break down, but it's not a perfect square, so the radical would not cancel out. You're still going to have, let me grab a different color, two real solutions, but they are going to be irrational. So still two real, no matter what, if you've got a positive discriminant, you've got two real solutions. It's just whether or not they're rational or irrational. Rational would happen if you have a perfect square. Irrational, this is going to be some nasty decimal is what that is. When you take a square root of any number that's not a perfect square, it's an irrational number. It's a decimal that goes on forever with no pattern. Both of these would be examples where if we had an actual graph, we're going to have two real solutions. So there would be two places your quadratic or your parabola would cross the x-axis. So both of these are two real solutions. It's rational if that number is a perfect square when you do b squared minus 4ac. It's irrational if it's not, just to distinguish between the two. Okay. So at the bottom, I just have a couple of questions here. Just says determine the number and type of solution. So we're just going to use the discriminant. And I'll write it right here so you guys can see it on the screen. B squared minus 4ac. All right, so I just need my a, b, and c values from my quadratic here. So b, so we're going to do negative 6 squared minus 4, a is negative 3, and c is 1. So if I square this, I'm going to get 36 minus, now if I do 4 times negative 3, that's actually going to turn this into a plus 12. So this guy, if I add this up, I'm going to get 48. Okay, so because I got positive 48, this is two real. It's positive, so it's two real. And that is not a perfect square, so I'm just going to jot down that they will be irrational solutions when I do that. But two real, number and type, so two, type, real. All right, now, b squared minus 4ac. So this will be 4 squared minus 4 times 1 times 4. So this is going to be 16. 4 times 1 times 4 is also 16. So I got 0. Now, if you get 0, this is one real solution. That's the number and type. And anytime you have 0, the solution is going to be something that you could write as a fraction. So that's going to be rational. Okay. And then the last one, discriminant, I don't know why I just put a negative, sorry, b squared minus 4 times a times c here. This is going to be 25, and then I'm going to do negative 4 times negative 2 times negative 13. So this is going to be minus 104, and if I go ahead and subtract that, we're going to get negative 79. So anytime your discriminant is negative, you're going to have two imaginary solutions there. Okay, now on the back here it says if the discriminant is a positive perfect square, then I know automatically I have two real rational, so it's not going to involve a radical, two real rational solutions from what we've been talking about doing the discriminant today. So if you do b squared minus 4ac, and you get a positive perfect square. So when I say perfect square, I mean like 1, 4, 9, 16, 25, 36, 49, those types of numbers. Okay, the other thing that is going to be something you want to know here. If you have two real rational solutions, that means the quadratic you are working with here is factorable. And so if you wanted to solve the quadratic you have, if that's what you're working on, you would know that this would be something that you could factor. And what we're going to talk about below here, just the different methods we've talked about for solving a quadratic and when it might be useful to use which one. Okay, so if you're going to solve by graphing, you need to have real solutions. So if I was going to use my discriminant, you would need real solutions, so b squared minus 4ac. If it was 0 or if it was positive, we could use graphing. In this case, if we're going to use graphing, I would either want to look at a graph, or maybe I would want to use my graphing calculator to look at that, to make that a faster process. But graphing is where you're going to want to look at the graph and see where it crosses the x-axis. So it's not always the greatest method. Factoring, if b squared minus 4ac is a perfect square, just like I mentioned above, then you will automatically know it's factorable. Or when we were doing this, if you can multiply a times c and add to b, if you can think of factors that will work with, then you have a factorable situation. Square roots, you want to use square roots. I'll give you a couple of examples, but basically I want no linear term. And so something that might be in that format, maybe I have like 3x squared plus 75 equals 0. That would be a good example of something. I would want to just solve that using square roots because I could get x by itself there. Another example, it would be, let's say we had, I don't know, x minus 4 squared equals 25 or something like that. In that format, you could if you wanted to, but I would not FOIL that out. If you've got a set of parentheses and you could just cancel out the square root and squared, that would be a good time to use square root. So if you have all multiplied out and you don't have an x term, go ahead and solve by using square roots. Or if you have a set of parentheses, isolate those parentheses that are squared. You can take the square root of both sides. Now, these last two, completing the square and quadratic formula, can be used on any quadratic. Both of these, quadratic formula and completing the square. Now, what I would say to you, you can't always factor, you can't always use square roots. You can always complete the square, you can always use quadratic formula. However, if I was completing the square and I was trying to find the fastest, easiest way to do this, I would not complete the square if a was not equal to 1, and I would probably not do it if the linear term was odd. So I would recommend, you can use completing the square on any quadratic, but I would recommend if your a value is 1 and the b value is an even number, that is a really effective method. If a is not 1 or if b is odd, it's a lot trickier to do and you're going to deal with fractions, and there might be another method that would be easier. If you do complete the square, the key to remembering is to complete the square to get that constant term. It's the b value divided by 2 squared. But when I would have a choice, I would say complete the square if your a is 1 and the b is even. That's the easiest time to use that. Quadratic formula, anything. You can use that on any quadratic. I wouldn't say there's necessarily an easier time than another. You can always use the quadratic formula. No a, b, or c value would necessarily make that easier or more difficult. So quadratic formula you could use on any question. So what I have down here at the bottom is just a couple examples of quadratic equations. And just to kind of think through, how would I maybe solve this? What would be the easiest thing to do? So if you wanted to test your discriminant, so let's just say I did this first one, I did the discriminant. So it would be b squared minus 4ac. So I'm going to just check this real quick here. And I got 49. So if that's a perfect square, this is factorable. So I could factor. Or probably in that case, if I've got a number in front of the x squared, maybe that would take me a little bit longer. So I would say on that one, if I had to choose, I would do factoring or quadratic formula, which I'm just going to write quad form to abbreviate that. I would not use completing the square on this because I've got a number in front of the x squared. I'd have to divide everything by 6, and that's not going to leave me with nice values. You could graph this if you wanted to. I got a positive value when I did the discriminant, but I would probably want to see my graphing calculator for that. So you could, I would say you could graph, and if I was doing that, again, I would probably use Desmos or my graphing calculator. But probably if that question was in front of me, I would either factor or use the quadratic formula. Okay, so let's check the next one. I would not use square roots because I've got an x term. Let's see what my b squared minus 4ac is. So I'm going to do 5 squared minus 4 times 1 times negative 8. Okay, so I got 57 when I did that. Okay, so I know this is going to be irrational solutions, so I would say I can't factor this. Now, to be honest, this wouldn't be too bad. I could complete the square, but I would be dealing with a fraction because my b value is 5, but it would be an option. Or if this was me, I would probably do the quadratic formula on this particular question. Now, if I'm looking at this right here, if you've got parentheses squared, I would isolate those parentheses and tell you the fastest method for doing this would be to solve using square roots. Get that parentheses by itself, take the square root of both sides. Otherwise, if you want to use the quadratic formula, or if you want to do factoring, or if you want to do completing the square, we would have to FOIL all of that out and then simplify it into a format we could use. So I would say square roots is the best option for letter C. Okay, letter D, let's do b squared minus 4ac. So 7 squared minus 4 times 1 times 10. I got 9 there. So b squared minus 4ac is 9. That implies, because that's a perfect square, this is factorable because that's a perfect square. So honestly, this particular question, I would factor if it was my choice. You can, again, you could complete the square or use quadratic formula. Completing the square, kind of like part B, would maybe be a little bit tricky here because your b value is odd, so you'd be working with fractions, but any of these would be good options. If it was me, I would factor this. Okay, now I just have an x squared here. I don't have any parentheses or any x. I would solve this using square roots. I could just add 1, divide by 16, and take the square root there. And the final question, how would I solve it? I'm just going to do, excuse me, b squared would be negative 6 squared for, 4 times 1 times 17. This gives me a negative number. You could not graph this because it would not intersect the x-axis. This should have 2 imaginary solutions here, so we need to use algebra to find those. So in terms of this question, probably if it was me, since that b value is even, I would complete the square here if I was doing this question. My b value is even. I just have a plain x squared. I don't need to divide anything to get x squared to be a coefficient of 1. So I would probably complete the square on this question. It's not factorable because I got negative 32 is not a perfect square, so it's not factorable. And it's not going to be factorable anyway because we're going to have imaginary solutions. So I would say complete the square here or quadratic formula. If it was me making the choice, I would complete the square, but you could do either one of those.